Hi guys, welcome back. This is the second video of two videos all about inverses, and today we're going to talk about all of the graphs of inverses and how we know if something is an inverse based off the graph. There's three really important things that we need to talk about that are true about inverses, and then we'll move on to the graphs. So the first thing is that f of x and its inverse have opposite x and y values, right? That's what makes it an inverse. So whatever the x values are for this function are now the y values for this function. The second thing is that the graph of the inverse is a reflection of the function across the line y equals x. So you'll see in these three examples we're going to do today, I already have three parent functions, and then I also have graphed y equals x in red, just so it's there so we can see that's the reflection line. The third thing is that the domain of the inverse is the range of the function and vice versa. That's pretty much the same thing as the first point, but it's just another way of thinking about that the x values are switched, and same thing with the y values. Okay, so first graph that I want to draw the inverse of is a line. You guys will see a couple of these for your homework. So we've got a line here, and I am going to graph the inverse. Now, a few things I want to do first. I'm going to point out just a couple points that are on this line so that we can write the points that correlate on the inverse. So the first one I see right here is the point -2, -2, -2. And I see one right here. This is the point -1, 1. And then let's do one more. I see the point 0, 4. Okay, you can do more or less than this, but this is just for notes purposes so you guys can see how these points change when we draw the inverse. So what we'll do for the inverse points is just switch the x and y values. So for the first one, they're the same, so that point's actually going to stay the same. For this one, now it's going to be the point 1, -1. And this one is going to be the point 4, 0. So now all I have to do is plot these 3 points. It's a line, so I really only need 2 or 3. And we're going to see where these fall. So the first one is the same as the original line. Then I've got the point 1, -1, and 4, 0. So with my straight edge, I'm going to connect these so that I can really clearly see the inverse function. Just like that. Okay, and you'll see that those are, in fact, reflections of each other over the line y equals x. Some people will just actually reflect the points. They won't do this math right here, but I like to do this just to make sure I do, in fact, have the correct points. All right, next one we're going to do is a cubic function. So if you remember from last unit, we've seen these before and how to graph these, but now I'm going to graph the inverse. So we're going to do something really similar. I'm going to point out a few of these points, and we're going to reflect them. So first I have the point 0, -5. I have the point 1, -4. And then I have the point -1, -6. So again, just like before, I'm going to switch the x and y values to find the points on my inverse. So now this is going to be the point -5, 0, -4, 1, and -6, -1. So now I've got some points that I can put on the graph. All right, so I have -5, 0, -4, 1, and I have -6, -1. Okay. I'm also going to reflect this one just so I can really easily see the shape so I don't mess that up. So if this is the point 2, 3, now I'm going to have the point 3, 2, like that. So doing your best to go in and keeping that cubic shape, you'll see that that is a reflection of the cubic over the line x equals y. So this is the shape of the inverse of this function. That would actually be a cube root function. All right, last one. This one's a little tricky. This is our parabola. We'll see why it's a little bit different in just a moment. So first, just like we've been doing, we're going to just point out a few points on that parabola and we'll reflect them. So the first one I see is this 0, 2. We've got 1, 3, -1, 3. And let's do one more actually. Let's do 2, 6. Okay, so our new points, remember switching the x and y values, so now I've got 2, 0, 3, 1, 3, -1, and 6, 2. Okay, so let's get those on the graph. So 2, 0, 3, 1, 3, -1, and 6, 2. Okay, so we'll see this parabola shape right here. So one thing I want to point out, because we're not quite done yet, is that what I have just drawn is not a function. So remember, if we pass a vertical line through, this would actually fail the vertical line test. So this is not a function as I've written it so far. What we need to change is half of this parabola should not exist, or half of this square root function should not exist. So let's zoom in a little and see why. Let's look at the original parent graph. Now remember, the domain and range switch for the function and for the inverse. For this range, I don't have any y values included until I get to +2. So the range is y is greater than or equal to 2, right? But then for the inverse, that means that's going to affect the domain, right? The range of the original function is the domain of the inverse. So if the y values have to be greater than 2, then the x values have to be greater than or equal to 2. All right, and then last thing I want to show is that if that's true, if the y values are greater than or equal to 2, then I can't have any of these values down here. So when we draw a square root function, we only end up getting this positive top of the shape. So you'll see anytime we draw the square root function or the inverse of a parabola, we have to take away all of the negative y values because we didn't even have them to begin with. Okay, well, thanks so much for watching, guys, and this is the second of our 2 on inverses.